the hidden wartime light that burned without fuel. There's a moment in every deep study of World War II survival tactics when you run into something so clever, so brutally practical, that it forces you to rethink what innovation really meant on the front lines. For soldiers living under blackout orders, rationing, and the constant threat of night raids, light wasn't just a convenience. It was danger. A single flame leaking through a tent flap could draw artillery. A lantern glow could mark a trench line for enemy bombers. At the same time, fuel was just too valuable to spend on anything non-essential. Troops needed illumination for medical work, map reading, equipment repair, and communication. But they had no room to waste oil, no tolerance for open flames, and no desire to risk their position. Out of that impossible equation came one of the most overlooked pieces of wartime survival engineering: the fuelless field light. This guide breaks down exactly how it worked, why it mattered, and how the same principles still offer real value for modern off-grid survivalists and preparedness enthusiasts. Why the fuelless field light existed at all. By 1942, kerosene, lamp oil, and even basic paraffin were being rationed across every front. Forward units received almost nothing beyond what was needed for vehicles, generators, and critical machinery. Infantrymen in dugouts, reconnaissance teams deep behind the lines, and medics working in makeshift shelters had to operate in near darkness. They needed a controllable, low-signature light source that didn't create smoke, heat, or flame. And so they turned to chemistry, improvisation, and battlefield necessity to build lighting systems that didn't rely on combustion at all. The key was calcium carbide, a compound that had already been used for decades in miners' lamps. When it contacts water, it releases acetylene gas. Fully ignited, this gas burns with a bright flame. But soldiers reworked the concept so the gas wouldn't burn openly. Instead, they used a slowed, controlled reaction and forced the gas through fine material that allowed it to glow rather than ignite. How soldiers built the chamber that produced light without burning fuel. The field design followed a simple set of principles: contain the reaction, slow the water flow, diffuse the gas, and harvest the glow. A metal can, food tin, or artillery shell casing served as the reaction chamber. Calcium carbide granules went at the bottom. Above them, soldiers placed mesh, cloth, or thin mica to restrict movement and keep solid debris contained. A small water reservoir was suspended above the carbide, often nothing more than a punctured canteen, a ration tin with a pinhole, or even a cloth wick that carried water downward through capillary action. Once the drip began, acetylene gas formed slowly and filled the chamber. Instead of channeling that gas to a flame tip, soldiers let it permeate through porous material such as gauze, clay, or layered cloth. The gas reacted, producing a controlled chemiluminescent glow. It wasn't bright enough to give away a trench line from the air, but it provided just enough illumination to read a map or check a compass. It didn't flicker like a flame, didn't smoke, and didn't heat the container significantly. Most importantly, it couldn't be seen from a distance, making it ideal for night operations in hostile territory. Why chemical lighting became a quiet backbone of hidden field work. These lamps filled a gap between no light and dangerous light. In cramped bunkers on the Eastern Front, underground medical posts in the Balkans, and jungle command positions in the Pacific, soldiers relied on low-signature illumination to stay operational without revealing themselves. The glow was steady, the reaction silent, and the materials easy to scavenge. because the byproduct was calcium hydroxide, a harmless paste. The lamps could be cleaned and reused endlessly. Some soldiers experimented with phosphorescent compounds, like zinc sulfide doped with copper to prolong the glow or soften the intensity for extremely sensitive operations. These adjustments created early tactical lighting long before the concept became standard in modern militaries. How this forgotten invention shaped modern off-grid lighting. Glow sticks, chem lights, mining lamps, and even certain emergency signalling tools all owe something to this wartime innovation. The basic idea remains unchanged. Store safe reactants separately, initiate a reaction when needed, and produce light without flame, fuel, or electrical systems. For survivalists, that principle is as valuable today as it was in the 1940s. Electricity fails, batteries drain, fuel spoils or runs out. But properly stored chemical materials can last for decades. Calcium carbide is still available for industrial metal cutting and caving equipment. A small amount and a controlled water drip can provide hours of usable light in an emergency. While modern chem lights are easier and safer to use, understanding the old carbide method gives you a tool with far longer shelf life and far greater versatility. How you can adapt this knowledge for real emergency use. A simple stainless steel container, a carefully controlled drip source, and a handful of carbide granules are enough to replicate the wartime system on a small scale. Modern metal tins, miniature water reservoirs with needle-sized holes, and fine mesh barriers create a compact, reusable light source that requires no batteries or fuel. It should always be used outdoors or in well-ventilated areas due to gas release, but the principle remains solid. It offers an option when power grids fail, when fuel cannot be sourced, or when silent, low-signature light is necessary. Why this knowledge still matters. The soldiers who built these lamps weren't chasing technological breakthroughs. They were trying to survive. Their solutions remind us that resilience is built on understanding simple reactions, available materials, and resourceful thinking. The fuelless field light is a perfect example of wartime ingenuity that still has direct relevance for anyone serious about preparedness, off-grid capability, or historical fieldcraft. If you value this kind of deep, forgotten survival knowledge and want more field-tested lessons from World War II's toughest conditions, make sure you subscribe to Warfront Survival, share this guide with fellow history enthusiasts, and keep these hard-earned principles alive.